this video, I am going to explain about metallurgy. So metallurgy is the process of extraction of metals from their ores. So first we will discuss concept session, that means synopsis. First, lesson structure: mineral, ore, flux, gangue, slag, matte, ores with formulae, froth flotation process, roasting, calcination, electrometallurgy, blast furnace, extraction of copper from copper pyrites, electrolytic reduction of pure alumina, Hall-Héroult process, methods of refining, composition of alloys, so uses of metals and uses of different types of iron. So first one, mineral and ore. The naturally occurring inorganic substances of definite chemical composition are known as minerals, or simply the substances, natural substances which are obtained by mining or minerals. So in minerals, metals are found in combined state. Next, ore. The mineral from which metal can be extracted conveniently and economically is called as ore. So simply you can say all ores are minerals, but all minerals are not ores. Next, flux. The external substance which is to be added to ore in order to remove gangue. Gangue means here impurities. Gangue means impurities. So very important, impurities. The substance which is used to remove flux, is flux. Here flux is of two types, acidic flux and basic flux. Flux, acidic or basic. So acidic flux removes basic impurities and basic flux removes acidic impurities. Very important definitions. So flux is a substance which can be used to remove gangue particles from ore. Flux is of two types, acidic and basic. Acidic flux removes basic impurities, basic flux removes acidic impurities. Here examples: acidic SiO2 P4O10, basic CaO MgO, commonly used fluxes. Next, gangue. The impurities associated with ore particles are known as gangue or matrix. It is also known as matrix. Gangue or matrix. Next, slag. The fusible product formed when gangue combines with flux is called slag. Here flux, Flux, flux. Flux. Gangue combines with the flux to form, say, ferrous silicate, FeO. Say that is gangue, that means impurity. Here flux can be SiO2. So FeO is basic. In order to remove basic gangue particles, acidic flux must be used, which is SiO2 silica. That forms FeSiO3, which is slag, ferrous silicate. So slag is always fusible material. Fusible means low melting point. It has low melting point. Next, matte. So matte is molten mixture of cuprous sulfide. So major amount of cuprous sulfide and a small amount of ferrous sulfide. It is known as matte. It is formed in extraction of copper. in extraction of copper, it will be obtained. We will discuss later. Next, ores with different formulae. So first, aluminium, most important, bauxite and gibbsite. So for aluminium, some more will be there. Aluminium, corundum, Al2O3, diaspore, Al2O3 dot 1H2O. Next, bauxite, Al2O3 dot 2H2O and gibbsite. Remember this. Al2O3 dot 3H2. Corundum, diaspore, bauxite and gibbsite. Here Al2 should be there. Al2O3. Here also O3. So very important. Next, zinc. Zinc blend, zincite. Or one more will be there, calamine. For zinc, calamine. Calamine, which is ZnCO3. Next, iron, hematite, Fe2O3 and Fe3O4. Fe2O3 and Fe3O4. So very important. Fe2O3 hematite, Fe3O4 magnetite, magnetic material. Next, copper, cuprite. Next, copper glans, Cu2S. Cu2S. So remember these ores and corresponding formulae. Next, Froth flotation process. Froth flotation process. It is based on wetting tendencies of ore and gangue particles. So it is based on preferential wetting properties with frothing agent and water. That means simply gangue and ore particles. So here ore particles will be weighted by oil and gangue particles will be weighted by water. So difference in wetting tendencies of ore and gangue particles. Ore particles will be weighted by oil and gangue particles will be weighted by water. That means if this is ore particle, so around ore oil will be there. Oil will be there like this. So it is best example for adsorption. Next, suppose if it is gangue particles will be weighted by water. So very important. So Froth flotation principle is difference in wetting tendencies of ore and gangue particles. Ore particles will be weighted by oil, gangue particles will be weighted by water. Next. So this is best example for adsorption process. Adsorption means only surface attachment. Only surface attachment. Next. So this is used to concentrate sulfide ores because these are lighter ores. So Froth flotation is applicable to Only sulfide ores, because sulfide ores are lighter when compared to remaining ores. Next, so in this process, powdered ore is added to water containing pine oil, which is frothing agent, which can cause froth. Next, sodium ethyl xanthate is added, which acts as collecting agent that collects all ore particles. Next, cresols and aniline are added as froth stabilizers. Next, the substances like lime, sodium carbonate are added to help the froth to float. Next, the suspension is agitated with a stream of air. The sulfide ore particles stick to the oil drops and rise to the surface in the form of froth. So these are separated and dried to get concentrated ore. So these are concentrated, that means copper pyrites, iron pyrites, galena, zinc blende are concentrated by froth flotation process because these are sulfide ores. Here ore and gangue particles, next oil and water, next collecting agent sodium ethyl xanthate, next froth stabilizers, activators and depressants must be also added. So CuSO4 also acts as activator. Next, NaCN depressant. If we want to concentrate only one sulfide ore out of two or more sulfide ores, NaCN must be added. Next, roasting and calcination. So first, calcination, the process of strong heating of ore in the absence of air or limited supply of air below its fusion temperature or below its melting point is calcination. So it can be applicable to calcination is applicable to carbonate ores and hydrated metal oxides. Hydrated metal oxides. See here, CaCO3 carbonate ore. On strong heating, it loses CO2 to form CaO. So on calcination, carbonates will be converted to corresponding oxides. It can be applicable to hydrated metal oxides also. Next, roasting. It is the process of strong heating of ore in the presence of air below its fusion temperature or melting point. So this can be applicable to sulfide ores. Sulfide ores. So example is given, ZnS, zinc blende will be converted to ZnO, corresponding oxide with release of SO2. Next, electrometallurgy. It is the process of extraction of metals by electrolysis of their fused salts. So here highly electropositive metals can be extracted by electrometallurgy. Next, copper can be extracted by hydrometallurgy. Hydrometallurgy means by using aqueous solution. Next, zinc cannot be displaced by hydrometallurgy. That means cannot be extracted by hydrometallurgy. So here three types of metallurgical process will be there. Electrometallurgy, next hydrometallurgy, and pyrometallurgy. So it is applicable to strong electropositive metals. Hydrometallurgy applicable to copper, silver and gold. So here strong electropositive elements means we know sodium, potassium, calcium, magnesium, aluminum, etc. Strong electropositive S block elements, and in P block aluminum. Next, pyrometallurgy applicable to generally D block or transition elements. So in that iron, copper, next zinc, tin, generally D block. Lead and so on, mercury, etc. So these are three types of metallurgical process. So electrometallurgy by using electricity, extraction of metals by using electricity. Hydrometallurgy, so extraction of metals by using aqueous solution. Next, pyrometallurgy by using high temperature. Metals can be extracted at very high temperature. Generally D block elements, iron, copper, zinc, tin and lead P block. So most of the D block elements can be extracted by pyrometallurgy. In some cases P block elements. Next, blast furnace. It is tall cylindrical furnace lined with fire bricks. It is used for the extraction of iron and copper. Blast furnace, vertical cylindrical furnace. Next, in blast furnace, different zones will be there. Different zones. So in extraction of iron, different zones. So here bottommost portion is combustion zone. Combustion. Here combustion takes place. Combustion zone. Next fusion zone. Next slag formation zone. Next reduction zone. So in combustion zone, C plus O2 will form CO2. Therefore, high amount of energy will be released. Therefore, temperature will be above 2200 kelvins. Next, zone of fusion. Fusion means that CO2 combines with C to form CO. Next, slag formation zone. Slag formation means Ca3. That means C, not Ca3. CaO combines with SiO2. That should be CaO plus SiO2 gives CaSiO2 slag. CaSiO3 slag. Next, reduction zone. So at reduction zone, iron oxides, that means hematite and magnetite, will be converted to iron. So this iron will be collected at the bottom and slag floats on iron liquid. Slag has low melting point, therefore it floats on molten metal. So here these reactions are very important. So which reaction is taking place in reduction zone of extraction of iron? Questions will be like this. Which reaction is not taking place? So Fe3O4 and Fe2O3 will be converted to metal, corresponding metal. Next, extraction of copper from copper pyrites. Copper pyrite CuFeS2. Next, first concentration. Concentration is also known as dressing or cleaning, removal of impurities. So copper is concentrated by froth flotation process because it is sulfide ore. Next, after that, roasting. It is strongly heated in current of air. So ZnS will be converted to ZnO. Similar to that of ZnS, I have let Cu2S will be converted to Cu2O plus SO2. Very, very important. Sulfide will be converted to corresponding oxide. Next, similarly, FeS also will be converted to, here zinc will not be there, FeS. Corresponding iron oxide. FeS will be converted to FeO. So in total, here MATI will be there. MATI contains large amount of CO2S plus small amount of FeS. This is known as MATI. So copper pyrites is combination of CO2S and FeS. So major amount of FeS will be converted to FeO and very small amount of CO2S will be converted to CO2O. So therefore, after roasting, the mixture contains large amount of CO2S and small amount of FeS. This is known as MATI. So after that, FeS will be completely removed from the mixer. After that, CO2S plus O2 gives Cu2O plus SO2. Next, the unreacted sulfide reacts with the formed oxide to form Cu plus SO2. This is known as self-reduction. Self-reduction. See, major amount of Cu2S will be converted to Cu2O. Little amount of Cu2S left in the vessel. So that unreacted sulfide again reacts with the formed copper oxide to form Cu, which is known as blister copper. Blister copper, which contains 98% of copper. Very, very important. So this is self-reduction. The metals which undergo self-reduction are, remember, self-reduction is possible with, remember like the HCP, Hg, Cu and Pb. These three metals undergo self-reduction. Self-reduction means, remember like this. First sulfide will be, some amount of sulfide will be converted to oxide. The unreacted sulfide again reacts with the formed oxide to form corresponding molten metal, impure metal. So in this case, the molten metal is known as blister copper, which is of 98% pure. Next. So blister copper can be purified by refining. Refining means purification. Blister copper can be purified by polling process. So polling process is used when, so here blister copper Copper contains 98% of copper and approximately 2% of oxide. So Pohling method is applied when metal contains metal oxide as impurity. This is impurity. So this can be purified with or refined with Pohling process. Pohling technique is used when metal contains metal oxide as impurity. So here this mixture is heated with green poles of wood. So this wood releases hydrocarbons which are reducing agent. So these reducing agents can reduce oxide to corresponding copper. We'll get copper which is of 99.5% pure. And this can be again purified by electrolytic refining. To get almost 100% of copper. This is the process. First blister copper 98%, next Pohling 99.5%, after that electrolytic refining. Check here, in electrolytic refining, impure copper acts as anode and pure copper plates acts as cathode. Copper sulfate is electrolyte. Next. See, electrolytic reduction of pure alumina. This is the extraction of aluminium. So, electrolytic cell contains iron box lined inside with gas carbon, amorphous form of carbon. Electrolyte, mixture of alumina, cryolite and fluorspar. So these two compounds are added in order to decrease melting temperature. So Na3, AlF6 and CaF2 decreases melting point of Al2O3 alumina and increases electrical conductivity. So very important. The purpose of addition of cryolite and fluorspar is to decrease the melting temperature of Al2O3 and to increase its electrical conductivity. Next, cathode. Iron box lined inside with gas carbon. Next, anode. Series of carbon rods or graphite rods. Next, electricity. Electric current of 100 amperes at 6 to 7 volts. Next, role of cryolite. Here it is given. Makes good conductor or lowers fusion temperature or melting temperature. Next. So general methods of refining. Pohling. This process is used when metal contains metal oxide as impurity. And in this process, the crude metal is heated with green poles of wood. These green poles of wood can release hydrocarbons which are powerful reducing agents. So those hydrocarbons can reduce metal oxide to corresponding metal. So copper and tin are purified by this process. Next, electrolytic refining. So here Cu, Ag, Au are purified by this method. So here impure metal acts as anode and thin sheet of pure metal acts as cathode. So molten or aqueous solution of metal salt is taken as electrolyte. Very important. So impurities settle down, which is known as anode mud particles. Next, zone refining. It is used to purify semiconductors. Ultra pure metals can be obtained by this process. So this is based on difference in solubility of impurities in molten state and solid state of metal. Ultra pure metals can be purified. Next, vapor phase refining. So in vapor phase refining, we have vapor phase refining. There are two processes, Mond process and Van Arkel process. So very important. Mond process is specific for nickel, and these are titanium, zirconium, hafnium and boron. So in Mond process, nickel solid is heated with carbon monoxide 4 moles. A complex will be formed NiCO4. So which on heating decomposes to, so here impure nickel will get pure nickel plus 4 moles of CO gas. This process is very important. Next, Van Arkel process. So titanium first heated with 2 moles of I2 to form titanium tetraiodide, which is volatile, which on strong heating gives, this is impure titanium. Use titanium pure plus again 2I2. Van Arkel process. Remember this process. Next. So composition of alloys, brass, bronze and German silver. Remember this combination. Brass, copper and zinc, bronze, copper and tin, German silver, nickel, copper, zinc. Easy to remember. Next. So uses. Zinc uses galvanizing and in batteries. Copper uses electrical wires, water stream pipes, making alloys. Next, iron, casting purposes. Next, wrought iron, which is purest form of iron, wrought iron. Anchors, bolts and chains. Next, aluminium foils, wrapping for chocolates. Next, paints, lacquers. Next, uses of different types of iron: cast iron, wrought iron, nickel steel and stainless steel. Remember the uses. Stoves. Next, gutter pipes, toys. Wrought iron, anchors, wires, bolts, chains, agricultural instruments. Next, nickel steel, cables, automobile, aeroplane parts. Chrome steel is making cutting tools and crushing machines. Next, stainless steel, making cycles, automobiles, utensils and pens. So next we will discuss worksheet questions one by one. Here first question, which are the following ores does not contain iron? So here I will write hematite. Hematite is Fe2O3, magnetite Fe3O4, calamine ZnCO3, Next, siderite. FeCO3. So which does not contain means calamine. Does not contain iron. Next question. Which of the following statements are not true about interstitial complexes? Interstitial compounds means, so interstitial compounds are formed by interstitial compounds are formed by C, H, N or B. These elements can form interstitial compounds due to small size. So these elements will be trapped in the gaps between metal atoms in metallic crystal. So what are the properties? Small atoms like C, H, N are trapped inside of crystal lattice. That is correct only. These are usually non-stoichiometric. There will be no definite formula for these compounds. Next, generally retain metallic conductivity. Conductivity will be retained. These are chemically very active. This is wrong. So why? Because these are chemically inert. Chemically inert. Here chemically active is given. Therefore option D. D is wrong. Somewhat stable when compared to pure metals. Next. Statement A. Magnesium can reduce Al2O3 above 1350 degrees centigrade. So magnesium can reduce, so here above 1350 degrees centigrade. Aluminium can reduce MgO. Next, below 1350 magnesium can reduce Al2O3 according to Ellingham diagram. Ellingham diagram. So below 1350 degrees centigrade, 1350 degrees centigrade, magnesium can reduce Al2O3 because magnesium graph is below Al2O3. Above 1350, aluminum graph will be below MgO. Therefore, below 1350, magnesium is better reducing agent. Above 1350, aluminum is better reducing agent. So here both statements are wrong. A and B are wrong. So below magnesium, above aluminum. Both statements are given wrong. Next. What is the slag formed during extraction of iron? So in extraction of iron, SiO2 is silica is gangue, which is acidic. So this can be removed by using CaO, which is flux, and metal oxide basic flux. So these two will combine to form CaSiO3, which is slag, which is fusible material. Fusible means low temperature. That means low melting point. CaSiO3C. So during extraction of iron, SiO2 is gangue, that means impurity, which is acidic in nature. That acidic gangue particle will be removed by using basic flux. That removes SiO2 in the form of CaSiO3 calcium silicate, fusible material. So this will be infusible material, very high melting point. But when it combines with flux, it will be converted to fusible material, low melting point. Here, very high melting point, which cannot be removed easily. Next. Option C. Next one. So copper matte contains copper matte contains large amount of CO2s plus small amounts of FeS. Therefore, option C. Large amount of CO2s, very small amount of FeS, that is copper matte. So FeS can be removed in the form of FeO by roasting. That will be removed. After that, CO2s undergoes self-reduction to form blister copper. Next, matching. The first nickel, A nickel gives, see here, Mond process. So Mond process means here 4. Next, B. Titanium Van Arkel. Van Arkel process 3. C. Germanium Zone refining. Zone refining is 2. Next, D. Copper electrolytic refining. Copper, silver, gold electrolytic refining. Aluminium also. So which is 1. Therefore, 4, 3, 2, 1. 4, 3, 2, 1 present in C option. C option. Next. So which of the following statements is not correct? So reduction of alumina to aluminium by magnesium is thermodynamically feasible. That is okay. Magnesium can reduce Al2O3. That is possible up to some extent. Next. The point of interaction of Al2O3 and MgO curves in Elling diagram is below 1665. That is also correct. Approximately 1350 degrees centigrade. Next, use of Ellingham diagram as reducing agent. Use of magnesium as reducing agent in metallurgy of aluminum is economical. Economical means profitable. Next, Ellingham diagram represents graphical plot of Gibbs free energy versus temperature for formation of oxides and common metals reducing agents. See here, third statement, use of magnesium as magnesium can reduce Al2O3 alumina, but the process is uneconomical. Economical. It can reduce alumina to some extent, that is based on temperature and Ellingham diagram graph. Therefore, this statement is incorrect. That is not profitable. Therefore, option 3. Next, copper matte is composed of. So copper matte is composed of a large amount of Cu2s and small amount of FeS, copper matte. So a small amount of FeS can be removed in the form of FeO, and after that Cu2s undergoes self-reduction to form blister copper. So option B. Cu2s large amount, FeS very small amount. Next, identify the metal which is not common to German silver and brass. Next, so brass contains zinc, copper and some amount of nickel. Some amount of nickel. Next, German silver. German silver contains copper, nickel and zinc. So here not common. So here remaining element is Fe is not common, not common to German silver and brass. Therefore option C. Next. So which are the following are carbonate ores? Carbonate ores. So you know magnetite, Fe3O4, Kaolinite will be AlOH, AlOH thrice and Si2O3. Next, siderite, FeCO3 and calamine, ZnCO3. Therefore, clearly 3 and 4 are carbonate ores. 3 and 4 option D. So check here one more point. This can be also written as Al2 Si2 O5 OH 4 times. So clearly option 3 and 4 are carbonate ores. These two are carbonate. Carbonate ores. Option D. So this is 1, 2, 3 and 4. Next. Electrometallurgical processes used to extract. Electrometallurgical process can be used to extract highly electropositive metals. So highly electropositive metals means sodium, potassium, calcium, magnesium, aluminum, etc. So here option. So in given options, Fe, Pb, Na, Ag are given. So iron, lead, silver can be extracted by pyrometallurgy, but sodium, due to high electropositive character, that can be extracted by electrometallurgical process. Therefore, option C. Option C, which is sodium. Very, very important. Next. So, which are the following process does not involve heating? So, calcination requires heating, smelting requires heating. Next, roasting requires heating, levitation. Levitation does not require heating. Levitation based on difference in specific gravities of ore and gangue particles or difference in densities. Difference in densities. Densities of ore and gangue particles. So this process does not require heating. Does not require or involve heating. Therefore D. For remaining, heating is required. Calcination, smelting and roasting. Next. So copper is extracted from copper pyrites by heating in a Bessemer converter. This method is based on the principle that. Next. Copper has, see options. Iron has less affinity towards oxygen. Next, sulfur has less affinity for oxygen. Copper has more affinity. Copper has less affinity for oxygen. That means iron has more affinity and copper has less affinity towards oxygen. So first we have to remove iron from iron, that means copper pyrites. From CuFs2 we can remove first iron because iron has more affinity towards oxygen. Therefore copper has less affinity for oxygen. Option D. First iron sulfide will be removed. Next. In extractive metallurgy of lead, reduction of the roasted ore to molten metal by heating with coke is known as smelting. So first Pb, molten metal Pb, first PbS will be roasted to form PbO plus SO2. So this PbO is heated with coke to form Pb plus CO or CO2, we can say CO2. So this requires temperature and this will be known as smelting. So here oxide ore, oxide form of ore will be converted to molten metal. Molten metal by treating it with reducing agent, which is coke, is known as smelting. Conversion of oxide to molten metal with heating is nothing but smelting. Option A. Next. Electrolytic refining is used to purify which are the following. Electrolytic refining. Electrolytic refining can be used for copper, silver, gold and zinc. So identify the set A. A is the option. Next. Oxidation state of copper is +1 in. See here, cuprate. Cuprate is Cu2O. So here copper oxidation state +1 and oxidation state -2. Therefore, cuprate. Option B simply. So malachite, azurite also we can write. Malachite. CuCO3 and CuOH twice. Here 2 plus and here also 2 plus. So azurite also we can write 2 moles of CuCO3 dot CuOH twice. In this also copper will be having Cu2 plus. Therefore option B. In cuprate copper has +1 oxidation state. Function of potassium ethyl xanthate in froth flotation process is to make the ore. So potassium ethyl xanthate is to make the ore water repellent. That is simply hydrophobic. Very, very important. Therefore, option A. So it becomes more water repellent. Therefore, that will be collected at the surface in the form of froth. Next. Copper is extracted from copper pyrites. By which process? Auto reduction process. Auto or self reduction can be done for mercury, copper and lead. So copper glance. First on roasting gives Cu2O plus SO2. So some amount of sulfide will be converted to oxide. Next, the remaining amount of sulfide reacts with the formed oxide to form impure copper, which is blister copper. So blister copper contains 98% of copper. Self-reduction or auto-reduction can be done for, remember, like HCP, mercury, copper and lead. Next. So for the formation of which compound in Ellingham diagram, delta G naught becomes more and more negative with increase of temperature? Simply CO. So C is solid plus half O2 gas to form CO gas. So delta G naught negative. That means more negative value. Towards more negative. So this is Ellingham diagram. Very, very important. Option A. Clear graph. Next. The reaction does not take place in blast furnace between 900 kelvins to 1500 kelvins temperature range during extraction of iron. So this reaction is not taking place. Fe2O3 plus CO will be converted to 2FeO plus CO2 is not possible. Not possible. Fe2O3 or Fe3O4 will be converted to Fe only, not FeO. Therefore, option A, it is not taking place. So here it is taking place between 500 to 800 kelvins. Therefore, between 900 and 1500 it is not taking place. Therefore, option A. Next. So, delta G naught versus T plot in Ellingham diagram slope towards, that means downward for the reaction. So, downward C plus half O2 gives CO, here solid, gas and gas. Delta G naught value is more negative. More negative means downward direction according to Ellingham diagram. Therefore, option C clearly. More negative value will be there, delta G naught. Next. So, which of the following metal is leached by cyanide process? Cyanide process can be used for AU and AC for purification of silver and gold. Option A. So, first silver, say this is impure, silver treated with NaCN, that means aqueous solution of NaCN in the presence of O2, it gives NaAgCN twice, complex formation. Next, this on treatment with zinc gives Ag plus Na2Zn Cn 4 times. This will be pure. Zinc acts as reducing agent. So very, very important. Similar process for gold also. So this one, sodium argentocyanide. Sodium argentocyanide complex. So here impure silver treated with NaCN, aqueous solution of NaCN in the presence of O2. It forms soluble complex. This is completely soluble complex. That means pure silver will be completely soluble. We can make pure silver into completely soluble material in the form of sodium argentocyanide. That soluble silver will be precipitated by using zinc, which acts as reducing agent. Next, metal which can be extracted from all three: dolomite, magnesite, and carnallite. So, dolomite, MgCO3 dot CaCO3. Next, magnesite, MgCO3. Next, carnallite, KCl, MgCl2 6H2. So these are minerals of magnesium. Therefore, magnesium can be extracted. Option C. Next, matching reverberatory furnace. That means A for copper. A for copper reverberatory furnace. Next, B, electrolytic cell. Electrolytic cell means electrometallurgical process, aluminium. So aluminium is present in second option, therefore 2. See, blast furnace for pig iron, that means C 1. D, zone refining silicon semiconductor 3. 4213. 4213, it is D. That means D option. 4213. Next, which of the following reactions does not occur during extraction of copper? It's CaO plus SiO2 gives CaSiO3. So this is gangue and this is flux and this is slag. It is during extraction of iron. Therefore, option A does not occur during extraction of copper. It is occurring during extraction of iron for removal of SiO2, which is infusible material that acts as gangue that combines with flux to form corresponding slag. Slag is fusible. This will be infusible and fusible. Next, the reaction representing Mond's process. So in Mond's process, first impure nickel, nickel solid, when heated with CO, that means carbon monoxide gas, first it forms nickel tetracarbonyl, which is volatile, and on strong heating it will decompose to pure nickel and 4 moles of CO. Mond process. Option A. Best method to refining nickel, impure nickel. Next. In the extraction of copper, its sulfide ore is heated in reverberatory furnace after mixing with silica 2. So here FeS will be converted to, iron has more affinity towards oxygen, therefore first iron will be removed from CO2s. FeO plus SO2. So this FeO combines with SiO2 to form FeSiO3, ferrous liquid. FeO gangue and SiO2 flux. This one slag. This reaction is occurring during extraction of copper in reverberatory furnace. So option A. Next. The methods not involved in concentration of ore. Concentration of ore. So liquefaction purification method. Liquefaction. Next, electrolysis. Or not involved in concentration of ore. Therefore A and C option. So leaching is concentration method. Ore is completely converted to soluble material. Hydraulic washing, levitation, that is also concentration method. Froth flotation, concentration method. These two are not concentration methods. Next. Assertion. In Ellingham diagram, the oxidation of carbon to carbon monoxide shows negative slope with respect to temperature. So it is correct, negative. Delta G naught value will be more negative. CO tend to get decomposed at higher temperature. This is wrong. Therefore, option A. A is correct and R is not correct. CO will not decompose. Next. In Hoare-Herald process, following is used to reduce Al to O3. Al to O3. So here first cryolite will be taken Na3AlF6. It can be written as 3 moles of NaF and AlF3. So first AlF3 will be dissociated to Al3 plus and 3F minus. Reaction at cathode, Al3 plus by taking 3 electrons will be converted to molten aluminum, but at anode F minus, take 2 moles, will be converted to F2 with release of 2 electrons. Next, this F2 reacts with Al2O3 to form AlF3 plus O2. AlF3 plus O2. So this O2 reacts with, here anode is graphite rod. Graphite. That graphite, that means anode carbon reacts with O2 to form CO2. Graphite. Let's see. Anode is graphite rod. That graphite reacts with O2 to form CO2. Therefore, graphite can be changed time to time. The weight of anode decreases time to time. Therefore, we have to change anode. So here option A. So at anode, graphite rod is involved. Next. Next question. See, this is the end of the chapter. In next video, I will explain one more chapter. All the best and thank you.